Welcome back. So we were talking about sectional charts before. One of our students was kind enough to provide this. This is a real chart, and this is actually the full chart from which I pulled the graphics that I was using on the slides that I showed you. So this covers the Los Angeles area. I'm sure you can all see that and read it, right? The one thing I want to point out, is, oh, thank you. See, there you go. Let's turn it around. I want to show them the legend. Oh, there you go. So on the right side here is the legend. So there's most of the symbols from the chart you can read if you go to the legend. Also, is there a legend in your guide? I don't think there is a legend in your resource guide, but there's a better legend online, okay? But there you go. That's a sectional chart. So you need to learn how to read those, because when you go for the knowledge exam, there will be tests that reference these charts. I think in the test that I took, and everyone's different, but I think there were at least half a dozen questions that reference sectional charts in the test that I took. Thank you. And I want to thank you all for coming back so quickly. I realize it was a short time. I hope everybody was able to get out and get a bite to eat. It struck me that I didn't mention this in my opening remarks, but if you don't, did you all get a copy of this resource guide? This is a guide that AOPA put together. Again, AOPA, for those of you who don't know, is the Aircraft Owners and Pilots Association. If you're serious about getting into this business, you should consider a membership in AOPA. They are probably the single biggest advocate for general aviation in the United States. All right, so we left off talking about traffic patterns. We're going to transition now to weather, and so let's get into some of the specific items you're going to want to check. Local forecast, obviously, the Weather Channel, they give you some information, but they're not going to give you information, any specific information that you need, like cloud ceilings and things like that. So it's a good place to get your initial check in. But then you're going to want to go to some of your more serious aviation products, and there's a lot of them out there. So this is 1-800-WX-BRIEF. And this is a place where you can go to get a weather briefing. You can also call that same number on the phone, 1-800-WX-BRIEF, and they will give you a weather briefing over the phone if you don't have access to online, or if you'd rather talk to a nice, friendly, live person. What you have to do when you call them is tell them where you're going to be flying, and then they will give you the brief, the METAR, and other information for that specific area. Funny, all these things work better when they're turned on. Amazing how that works. As I stumble around here. Sorry about that. Okay, so again, we talked about this visibility, 3 miles of visibility from the control station, the distance from clouds. You have to. All of these are considerations as you make your decision as to whether or not you can go fly this mission on the day of the flight. Wind at 10 knots or less. I have, and I was telling somebody about this earlier. In my contract, I have a clause that says that I reserve the right as the pilot in command to cancel the engagement for any reason related to safety. And specifically, I have a clause in there that deals with wind speed. And I set a limit of 14 miles per hour. And the reason I do that is because above 14 miles an hour, you could have some control issues with your drone. Now, you may ask, how do you know if it's 14 miles an hour at the site? And the way I do that, the way I get around that, and also the way I stop myself from being the bad guy in situations like this is when I get on location, if there's a question about wind speed, I have a pocket-size anemometer. That's a little wind meter. I put it up on a tripod stick, and I put it in the air, and I get a wind speed meeting. And if it's above 14 miles an hour, I can make the decision to cancel or reschedule the mission. So those are the kinds of things that you need to think about, because honestly, if you get on site and the wind speed is high and somebody's saying, oh, come on, can't you do this? You know, do we really have to reschedule? Well, yeah, you may have to, but you want to use something, you know, make somebody or something else the bad guy if you can. That's why I have the anemometer. Oh, also, the wind at 300 or 400 feet is probably going to be a lot different than what you're feeling on the ground. You know, you may feel little or no wind on the ground, but 200 or 300 feet up there, you could have some significant wind and wind gusts. So just something to be aware of. So there are two types of weather reports. There's the METAR, which stands for Meteorological Aerodrome Report, and that's exactly what the name implies. It's a report about the current conditions. The other one is a TAF, which stands for Terminal Area Forecast. And as the name implies, that's a forecast for a specific airport area. These forecasts are typically for a 24 to 30 hour period. And you're going to want to learn how to read them, because there will be or may be some questions in your FAA Part 107 knowledge exam. So is there any pilots in the room who want to help me decipher this? Well, we know, okay, we know what the first one is. What's that? That's the airport, okay? FDK, which happens to be Frederick, Maryland. It's the Frederick Municipal Airport. The next field, 051853Z. What do you think that means? Well, the 05 is the day of the month. And what do you think 1853 is? It's the time. We heard some people say the pilots said Zulu. That's what the Z stands for. Who here does not know what Zulu means? Everybody knows what Zulu means? Okay, so thanks for being honest. So Zulu is simply Greenwich Mean Time, or UTC. Okay, it's the aviation way of saying universal time, right? Why do we always have time stated in universal time in the aviation world? Because pilots fly across time zones all the time, and they need one standard point of reference. As opposed to the time zone they're in, they want a standard point of reference for the time, and that's why we always reference Zulu time. Make sense? Okay, so that's the next field. Okay, the third field, any guesses as to what that might be? Wind speed index, right? So what is a 090? Wind direction. Where it's coming from. The wind direction is where it's coming from on the compass. So where is this wind coming from? 90. Due east, right? It's coming from due east. And what's the wind speed? You ought to be able to figure this one out. It's the next four digits. 20 what? Knots, thank you very much. Okay. Whoops. Sorry. Push the wrong button. User error. 10 SM. What do you think that might mean? Thank you, sir. Visibility is 10, what's an SM? What are an SM? It's a statute mile, okay, as opposed to a nautical mile. What is this? Cloud cover. Few clouds at what level? 5,500 feet. Thank you very much. See, we got a show off over here. 5,500 feet. So there are few clouds. So what helped me out here? What's the graduation of the terms they use? There's few, scattered, broken, overcast, right? And when you get to broken or overcast, you've got a full cloud layer. That's considered a ceiling, thank you, which is the ceiling under which you have to be 500 feet. So if you've got few or broken under the ceiling level for you relative to clouds, you're okay, right? You can fly under a few or broken clouds, but you can't fly less than 500 feet close to a cloud layer that is either broken or overcast. I know this is a lot of information, but that's the way it is, folks. What do you think that might be? 2917. That's your temperature and dew point, right? So the current temperature is 29 degrees. The dew point is 17. Who can tell me what the dew point is? What's the dew point? 17, but what is a dew point? What are a dew point? Moisture, thank you. Exactly, and that's the answer. That's the real technical answer, is the air temperature at which moisture will condense out of the air. And why is that important to you as a pilot? Because it becomes visible, and it can also create ice on your wings. That's why this is a key measurement for pilots, okay? Not so much for drones, because you're probably not going to be flying at the dew point, and if you are, the risk is relatively low. But for pilots, icing is a big deal, right? You get ice on the wings, you lose lift. You can fall out of the sky. So that's why they have the dew point measurement. A3012. What's that? It's a reference point for the pilot to set the altimeter. That's the altimeter setting that they're going to use in order to make sure that their reference is right. And the reference is relative to density altitude. That's what they use as the basis for calculating density altitude. And then this last one is really obscure. RMK is remark, and A02 means the site is automated and has a precipitation sensor. Okay? So there's your METAR. Honestly, if you want weather information, yeah, you should really learn to some degree how to read the METARs, and there's some great reference material in your resource guide, which is this thing. I believe there's some great reference material in there on TAFs and METARs in terms of decoding them. But once you're done with the knowledge exam, you're probably find yourself going to one of these graphical weather sites more so than using this. You still should know how to read it, though. Okay, so how about this TAF? Well, we will decode a TAF later, but I want to talk briefly about aviation weather in terms of time. What would be the best time to fly today based on this chart? What time would you go flying? 8 a.m., 12 noon, 7 p.m., or 11 p.m.? 8 a.m., thank you. And why? Low wind speed, right? You want to, so there's a real reason, and the truth is, in most locations, the wind speed's going to be lower in the morning, and early morning and early evening than any other time of day. So those are your best times to fly. As it happens, from a photography standpoint, those are your best times to get good photographs too. When the sun is at a low angle on the horizon, you get better light. On the other hand, if you're doing something like an inspection and you want overhead light, then you have to fly in the middle of the day. You may be faced with some higher wind speed conditions. Okay, we talked about, let's look at a graphical version of the weather. See if I can get my cursor working here. Hang on. I apologize, but for some reason, if I get partway through these presentations and my cursor goes to sleep and I can't control it, so I can't point at things. So here we go. This is the Aviation Weather Center. And this is a live shot graphically depicting the METAR, okay? So what you're seeing here There's a pointer that doesn't work. Let's see if this one does. Here we go. What's this? This is the Gulf Coast, right? This is the hurricane that's down there right now. So that's called a SIGMET, which is a significant meteorological event. And that's why it's color-coded, okay, in red. You see SIGMET here? This is a SIGMET. The whole area, lower Texas and Louisiana, is in a SIGMET right now. Who knew you were going to learn all this about weather, right? We're going to make you a meteorologist before this is done. Okay, so we talked about Z time. I don't have to talk about that, right? Everybody gets it? Any questions? Okay, good. Morning of the flight, what are you going to do? You're going to pull up your METAR and your TAF. You're going to look at the weather. You're going to look at other perhaps online sources. You might call 1-800-WX-BRIEF if there's any questions that you have about the area. And you might get a METAR. So let's decode this one. I'm going to do it for you, though, as opposed to making you crawl through it. But we'll talk about it a little bit. It's very similar to the one that we were talking about before. KFD, that's Frederick Municipal Airport. Remember, this is the second day of the month at 1647 Zulu. The winds are out of 310 at 9 knots. Visibility is 10 square miles. Clouds are broken at 5,000 feet. Remember, always add 2 zeros to the cloud level. What's this 06 M for? Temperature is 6 degrees centigrade, but what is M for? M is minus, simply minus, okay, minus 4 degrees. A3016 is the altimeter setting. So it starts to make sense, doesn't it? Are you guys experts now? Oh, I'm sorry. Did I skip that? Did I skip visibility? Sorry. I'm sorry. Thank you. Thank you. See, this guy's keeping me honest here. Thank you for that. I said 10 square miles. 10 statute miles is the visibility. I apologize. Thank you. No. No, the question was 10 square miles and 10 statute miles the same? No, sir, not at all. No, I'm sorry. Well, thank you for keeping me honest, but those are statute miles. 10 square miles would be very different than straight ahead statute miles. So, yeah, thank you for that. Somebody's always got to keep me honest, right? Thank you. Okay, where are we here? Oh, I like this. Can you guys see this weather forecasting stone? I don't know where they got this thing, but I got a kick out of it. If the stone is wet, it's raining. If the stone is dry, it's not raining. If the shadow is on the ground, it's sunny. If the stone is jumping up and down, there's an earthquake. If the stone is gone, it's a tornado, right? So there's your weather. The point is, get your weather forecasting or your weather information wherever you can, whatever gives you the information you need. There's no one absolute or single source for weather information, but get information that you can use. All right, so we're going to change gears a little bit. We're going to talk weight and balance. We'll talk a little bit more about the importance of the pilot in command. We'll talk about this concept of pulling G's, which is called the load factor. We've talked already about this, but it deserves one additional point of emphasis, and that again is the fact that you, as the drone pilot, the licensed FAA Part 107 certified remote pilot, are the pilot in command, singly and individually and solely responsible for what happens on that mission. If it crashes, it's your fault. If it hits somebody or something, it's your fault. If you lose the control link and it flies away, it's your fault because you were in command. So you're the head honcho. I think we made that point. The point here is, can you imagine a situation where being the pilot in command might be important? The example, and the answer is, just to kind of help you guys out here, is if I'm working with a crew, there's got to be one final arbiter that says go, no go. Or if we're in a situation where we need an emergency response, I'll take all the input I can get from everybody and everything that's around me, but I have to make the final decision, right? That's why it's important to have one person who's responsible for making that decision, as opposed to a bunch of people running around trying to figure out what to do. That's the whole concept of the pilot in command, and how it really grew up in the aviation world, in the manned aviation world. So you respect your authority. You are the pilot in command. You're not the drone owner or the store manager or the station manager. You're the pilot in command. But be polite and try to accommodate people, because honestly, especially if you get into an emergency situation and weird stuff is happening, somebody might have some good input for you. And as I said earlier, filter it and try to break out who's just trying to harass you with BS versus who's coming in with real and useful information. Take the useful information and put it to use, and throw the rest out, right? But you got to learn how to filter this stuff. Key to that is identifying crew roles ahead of time. Make it clear so that I'm the pilot, you're the visual observer, maybe you're my bouncer. I have a position sometimes on my flight crews that I call the bouncer. What do you think that person's job might be? If I'm the pilot, I've got my visual observer standing next to me, or maybe I've got my visual observer on 100 feet away and we're talking via some kind of a radio, okay? But what do I have? I have a bouncer. What does he or she do? They keep people off my back when I'm flying, right? Because ultimately, if there are people around, they're going to want to approach the pilot. They're going to ask questions. Some will be, stupid questions. Some will be honest, curious questions. But you got to pay attention to your flying, right? You need to get these people off your back. I run what I call a sterile cockpit environment. What does that mean? That means I'm the pilot and nobody else gets in. If you come and try to talk to me, you're not getting in. And if I can, I'll have a bouncer to keep you out. If I can't, I may have to be rude and just ask you to shut the hell up, right? And that's in the interest of safety. I have to focus on what I'm doing. So you should be strict about that. Try to maintain a sterile cockpit. Speaking of what can happen, there's a link here. I'm not going to take you out to it because it's a pretty lengthy transcript of what happened on this Eastern Airlines flight. But basically what happened, this goes back to, when was this? December 1972. They were flying an L-1011, Lockheed L-1011, which was a beautiful airplane. Does anybody remember that plane? What a beautiful aircraft, right? Rolls-Royce engines. It was a beautiful airplane. I wish it was still in service. So they departed JFK for a flight to Miami. The flight was uneventful until the final approach to Miami, and they put the landing gear down, and the light that comes on the control panel that indicates that the landing gear is properly deployed was not coming on. So now they're trying to figure out, is the landing gear properly deployed or not? Or is it just a light bulb burned out? And I'll make a long story short because there's about 5 pages of transcript here, but what happened, unfortunately, was that the pilot, and he had a co-pilot, and it happens on this flight, there was a flight mechanic as well. So there were 3 people in the cockpit. The pilot sent the co-pilot down initially to look at the landing gear. He couldn't figure out what was going on. Co-pilot comes back up. They start looking at the light on the dashboard to see if the bulb's burned out, but they can't get the cover on the bulb off to look at the bulb to see if the bulb's any good or not. So they're screwing around with the bulb. Meanwhile, the flight mechanic now goes down to look at the landing gear below. He can't tell what's going on. He comes back up, and they're still screwing around with his landing gear, and they're trying to figure out the light bulb situation, and they drive the plane into the ground because they're not paying attention to their altitude. They crashed. And a lot of people died. So the point is, pay attention to your flying. Not a pretty story, I apologize. we talked about flight characteristics. Considerations there, what's your payload? Are you overweighing are you overloading the plane or the aircraft? Your empty weight. Now your drone manufacturer will always state, and they'll give you at least two measurements. One will be the empty weight, and that should include the full system and all of the hardware that goes with the airframe itself. May or may not include the battery, so make sure you decipher from their measurement whether that weight measurement includes the battery, the weight of the battery or not. So they're going to have the empty weight with or without the battery, and then they're going to have what they call the all-up weight, and that's empty plus payload, okay? Sometimes you'll hear the payload specified separately by itself, but most of the time it's empty weight and then all up weight. And in order to figure out the payload, you just subtract the empty weight from the all up weight, and that's the payload you can carry and still have proper flight characteristics or performance standards on the aircraft. So this is a camera that goes on the Inspire 2. I'm not sure if they have the X5 over here on the Inspire 2 right now. I didn't look, but it's probably what they have with it. It's a very sophisticated camera. As I mentioned earlier when I was talking about the Phantom, these cameras that DJI puts out are very purpose-built. They've taken away all the hardware that go around a normal camera, like the case that you have to hold and things like that, optics and lenses that add a whole bunch of extra weight, right? And they've stripped it down to the bare essentials, but still maintain the quality optics and the quality sensor that you need. Then they've mounted it on a very sensitive gimbal. This is a great rig, the Inspire 2. I love it. It's very highly used in the cinematography industry. So this is a great camera, but it's not always going to be that easy. Your payload can vary significantly, and we talked about this earlier when I was using Don's camera as a prop, right? If you get a big camera up there, and it's got a zoom lens. And remember I mentioned with the zoom lens, sometimes they have what's called external zoom, which means that the lens gets physically longer as you zoom it. Some of these less expensive lenses will, if the aircraft, say that the lens is normally, this is a horizontal angle for the lens and it's zoomed to this point. If the aircraft points down, the simple weight of the downward weight of the lens may cause the lens itself to extend. That's a kind of a less expensive, non-professional lens might do that to you. And what happens then is what? Your lens gets longer. You weren't even controlling it at that point. It happened by itself, and the center of gravity is changing, so it's going to throw your balance off. So these are real risks and real factors that you have to look at. Another consideration relative to weight and balance is, and we've talked about this, the limits, power requirements, and battery life. Flight time is a real consideration with heavier loads, so make sure that if you're going to carry, if you had, I don't care what kind of drone it is, but you've got a drone, maybe you built it yourself, and somebody calls you and says, can you carry my 10-pound camera? The camera weight with the gimbal is 10 pounds. You know what I do before I even answer the question? I'd strap a 10-pound weight to the bottom of my drone and I'd go fly it and see how long it flies and what the flight characteristics are. It gives you a feel for what your duration is going to be, right, the flight time, and how this thing's going to handle with a stable load. Now, it's going to be a little bit different when you put a gimbal and a camera under it, but it gives you a pretty good idea of how it's going to handle. Sounds kind of stupid, but it really works. All right, we talked about this. Let's talk about G's. So what is a G? 1 G is the force of gravity. It's what you weigh when you're standing on the ground. Or when you're in the air. The G's are the same unless you get up into outer space and then you're weightless, obviously. But if you're in the air or on the ground, 1 G is a G. It's what you weigh. It's what the aircraft weighs. What is this chart telling us? What it's telling us is that if I bank 60 degrees my load factor doubles, right? That aircraft, when banked at 60 degrees, weighs twice as much, effectively, because its centrifugal force is having an effect of adding a load factor to it, right? So honestly, my hand's at roughly a 60-degree angle now, okay? You're probably not going to fly your drone at a 60-degree angle. Not too many will fly at 60, but a lot of them will fly at 45 or 40, right? And you have to consider the load factor there too. What is 45 is 1.4x. So at 45 degrees, if you're banking at a 45-degree angle like this, you've got a downward-outward force pulling on your drone of 1.4. So something to think about. Just be aware of these load factors and how they can impact your performance and handling characteristics. And you get back now to this notion of stall, right? Could you stall an aircraft? Could you stall a quadcopter in a 45-degree bank with a marginal load? Absolutely. You could fall out of the sky. If you've got a marginal load to begin with, and you reduce your lift because you're now at 1.4 Gs, you could fall out of the sky. So be careful. Be aware of these. That's why the FAA has these as part of the knowledge exam. We talked about this. Humidity, density altitude. What happens with density altitude? At 1,000 feet MSL on a 100-degree summer day, the effective density altitude may be 3,000, right? Why is that? Because hot air is less dense than cold air. So you're losing the air density, therefore you're losing lift. Your propellers are spinning at the same rate, but they're not generating as much lift. And the question then becomes again, do you have enough power in your system to override the lift that is absent because of the density altitude? Okay, let's talk about pre-flight checks. We'll switch gears here. Are checklists important? Pilots, do you use checklists every single time you fly, right? Without fail, right? Thank you. Every single time. It's easy to fall into a pattern that says, oh, look, I've flown this thing a lot. I mean, I know this drone inside and out. Use a checklist. Most manufacturers today, or I shouldn't say most, but many manufacturers will give you at least a hardware checklist for the drone. You know, you want to check it, just take a look at it. Are all the screws tight? Are there any wires hanging out that might be loosely connected or worn? Are the propellers secure? Is the camera and the gimbal secure? What about my control surfaces, right? My propellers. Are they secure? Are they solid? Do they have nicks in them that are going to cause me a decrease in performance characteristics? All these things, you should have a checklist, and every single time you fly, you should use it. What about, is the compass calibrated in the drone? This is very important, because if the compass isn't calibrated and you go into a return to home failure, it doesn't know where the hell to go, right? So these things are important. You want to make sure you don't overlook them. And the only way to be sure is to use a checklist. So don't get cocky. Please make a checklist if the manufacturer doesn't give you one, and use it every single time you fly. Are the batteries charged in the aircraft and in the controller? Oh, and does the gimbal have a separate third battery? Is it charged? What about all the control links? Are they working properly? Check all this stuff before you even hit the arm the props. Yes, sir. So the question was, as far as calibrating the compass, isn't that a computer chip? Well, there's actually a physical compass on the aircraft. It's a magnetic compass, and I could show you where it is on the Phantom if you wanted to look later. But it's a little piece of metal about that big, and it straps onto one of the legs. And what you're doing when you calibrate the compass is you're physically rotating the aircraft, and that gives a compass You do a 360-degree rotation horizontally, and then you tip it up on its nose, and you rotate it again 360 degrees, and that gives it a 360 calibration in the horizontal and also the vertical positions, and that's where you're getting the coordinates set for the home point as well. So the question is, given that the drone is generally speaking, under ideal conditions, working under GPS automation, why do you even need a compass? And the truth is, the compass and the GPS system work in tandem with each other, so they work together. Honestly, I can't give you a deep technical answer to that, but there is a need for both of them, and they do work together. I wish I could give it. I'll find that out, and I'll get back to you. Okay? Give me your email address. Okay, checklist. We talked, also, don't forget to talk about the weather. Look at the weather and make the weather part of your checklist. And oh, by the way, speaking of checklists, I personally, I have a checklist that I've created over the years, and it's 7 pages long. And it's a lot more than just the aircraft checklist. It's the pre-mission. I call it my mission execution checklist, because it starts with the first client call, and it gives me the information about the client, where we're flying, what we're doing, what kind of camera we're carrying, what kind of gimbal we need, what's the aircraft I'm going to fly, who's going to be the pilot, and then I get into things like hardware and software checklists and things like that. So you can expand this for your own purposes and have a document that is really effective in helping you do all of your flights, and not just the flight itself, but the entire mission from end to end. Sorry, getting out of control again here. Hang on. Okay, so what if you see issues? You got to troubleshoot them, right? Troubleshoot them before you fly. Make sure that what you're doing, what you're flying, is a stable and functional aircraft. What if you're up in the air, you're flying the mission, and all of a sudden something weird starts to happen? It was normal, a minute ago, but I don't know, something's just not quite right. It's not responding properly to the control inputs. What do? You bring it back, you put it on the ground, and you look at it, right? No problems found on inspection. Do you go back up and fly the mission? I got a thumbs down over here. Okay? This is from a pilot. Thank you. What I would say is, until you can identify a possible cause and make an attempt to remedy that cause, then and only then would I go up for a test flight on a very limited basis. And I certainly would not agree to fly the mission again until I was absolutely sure, having done a repair and having conducted a test flight, then I would agree to go fly the mission again, okay? But you should ground yourself. If you find something weird going on, you just don't want to go there. Thank you. So, hang on. Yes. So the question was the control frequency, the radio frequencies used by the control system. So it varies from manufacturer to manufacturer. Often what you'll find is the control frequency is at 2.4 gigahertz, and the video downlink frequency will be somewhere around 5.6 gigahertz. Okay? And the reason for that is you want to use the lower frequencies for the control frequency because lower frequencies reach farther in terms of radio waves. It's a matter of radio wave physics, okay? A lower frequency has further reach and a better chance of getting through trees and maybe even around buildings. Probably not at 2.4 gig, but I use a control frequency on one of my aircraft that I built myself of 433 megahertz, which is a much lower frequency, and I can control that thing 20 miles away if I could see it, okay? So, and then the reason the downlink frequency is different is because you don't want the two frequencies colliding. So you use the video downlink frequency at 5.6 gigahertz is the frequency that's most often used. So the possibility of frequency interference, if you go back to the early days and maybe even the not so early days of RC flying, that was a problem. And remember, if you were an RC flyer at a field, you would literally get a flag with a number on it that says, I'm flying at this frequency. Don't anybody else tune your transmitter to that frequency because you could make me crash. Okay? That's not an issue anymore because of the fact that these transmitters now operate digitally, and they set up a proprietary link between the transmitter and the receiver, and that frequency in some cases is a unique frequency that's established at the time of power on. So it may change every time you turn the aircraft on, and in some systems that frequency actually changes dynamically while you're controlling the aircraft. It bounces around for that very reason, because you don't want signals colliding. Did I answer that right for the RC flyers in the room? Okay, thank you. I don't want to say bad stuff here. All right, so I got to set this up. This is, you can see here, an Inspire 1 sitting in the middle of a street, and this pilot is about to do a real estate shoot for an MLS listing. So that's the setup. Check it out.
It's recording now, so we'll hold it still and we'll see if it does any shimmying. And, okay, everything says it's safe to fly.
The home point has been taken.
Yeah, at least we got that on video.
You got to laugh, right? I mean, so here's the deal. I was at Interdrone. Anybody know what Interdrone is? It's an industry conference in Las Vegas. It started 2 years ago. I'm proud to say that one of my videos was in the film festival there, and I was a finalist. So I'm at Interdrone in one of the sessions on cinematography. This is in 2015. And the presenter shows this clip as a demonstration of why you should make sure that your systems are okay before you fly. Well, it turns out that in the room, in that audience with me, is the pilot who was flying this drone when that clip was shot. And he says, he raises his hand, he gets up, he said, that was me. What happened was I had just updated the firmware on my Inspire 1, and I hadn't tested it. I took it right out to the field, turned it on, and I was going to fly this residential real estate shoot. And it flew right into the garage. And guess what? Not only did he get to buy a new drone, he got to buy a garage door too. So what's the moral of the story? Well, first of all, the rest of the story is, this is early in the days of the Inspire 1. So he sends this video to DJI, the manufacturer. They send him a new drone, and they ask him to take the clip down from YouTube. Well, he did take the clip down, but when I was putting this slideshow together last week, I got to this slide about the fact that you should have checklists. And I remembered this clip from this conference a couple years ago, and I said, let me see if I can go find that again, because I think it's very appropriate. Here's what I do. Whenever I update the firmware, and you're going to find with the newer drones, especially from DJI, and I'm sorry to keep referencing DJI, but they are the gorilla in the room, okay? You're going to find that with the more recent generations, especially, like the Inspire 2 and what we have here, the Phantom 4 Pro, there are sometimes firmware updates that come out every couple of months, so they're fairly frequent. What I do every time I get a firmware update is I download it and I apply it, and then I go out in the front of my house into my cul-de-sac and I tie a 100-foot rope to this drone and I fly it tethered. Before I ever fly it, before I ever set it free, okay? And the reason I do that is this video that you just saw. So that's what I do. What you choose to do is up to you, but that's what I do. He said the question was, before the crash, didn't he get an all clear? And yeah, the system gives you an audio, I think it says the home point has been set, ready for takeoff. And you could hear that in the audio here. So yeah, the system, it said, hey, it's good, but not so good. Okay, let's talk about radios. Why do you want a radio? This is handheld aviation radio I'm talking about. I mentioned the Yaesu 750L before. That's my radio of choice. Why do you want one? Well, you want to be able to talk to air traffic control if necessary. Now, honestly, if you're a licensed Part 107 pilot and you're flying with authorization in controlled airspace, the FAA will probably not say that you're going to be in direct communication with the control tower unless there's an emergency. In other words, you're not going to be out there 2 miles away from a Class C airport and call the air traffic control tower for that airport and say, okay, I'm getting ready to take off, right? That's not the level of communication that they're set up to handle. They just can't handle that volume of communication. So you're not going to want to do, but you want it for an emergency. If something happens, if this thing gets in a flyaway situation, you want to contact the control tower and tell them what's going on. It's headed in that direction and it's at that altitude. Tell your other airplanes in the area to watch out for it. You want to also, and more importantly, you want to be able to listen for air traffic in the area, like I talked about earlier. And listen to those traffic patterns so you know where the aircraft are and how to stay out of their way. Because does anybody else have the right of way? Do you have the right of way over anybody else as an RC pilot? No. Everybody else has the right of way. If somebody comes into your airspace, you get out of the way. Period, end of story. And I don't care if it's a 747 or a hang glider. You're the last man on the totem pole and you get out of the air. Oh, CTAF frequencies. So let's talk about frequencies on this slide. What do we have here? This is Eugene Airport. And you see 118.9 followed by a C in a circle. That C is CTAF. So whenever you see that C in a blue circle following the frequency, you know that is the CTAF frequency. What's that? It's the common frequency if the control tower is not open. What does this chart tell you? Well, it tells you a lot. Is that a... Hang on. We'll try this. Is that a towered or untowered airport? Towered. It's in blue, right? If it were untowered, it would be in magenta. Okay? So it's a towered airport. It's what class of airspace? Class D, Delta. Okay? This is the Eugene Airport. The control tower, CT, the frequency is 118.9. The star tells you that the control tower is only open part-time. It's not open 24/7. So at those times when the control tower is not open, the C tells you that you use the CTAF frequency, or excuse me, you use the control tower frequency as the CTAF. Okay? This other frequency here is a second frequency for the control tower as well, and that would only be operational when the control tower is open. Then you have this thing called ATIS, which stands for Automated Terminal Information System, and this is a recorded loop of weather and runway information right at the airport. And finally, you have this frequency called 122.95, and that's the Unicom frequency. And that is, at private airports, sometimes there's a facility that may have a Unicom frequency. It could be a ground services facility. They may do something like provide fuel, or if you call them and you want to have a taxi waiting for you at the airport when you arrive, that's who you call, and that's the frequency you use for that is the Unicom frequency. So you've got five different frequencies, right? No, I'm sorry, 4, right? Control tower / CTAF, secondary control tower, ATIS, and Unicom. And by the way, you could decode all this in that legend that I showed you on the sectional chart. It'll tell you what each one of these frequencies means. So how do you use this radio? You use the 4 W's: who you're calling, who you are, where you are, and what you want. In this example, shown below in bold, you're at the Frederick Airport, and you're making a call to let aircraft in the area know that you're going to be flying. Why? Because this is an untowered airport. You're going to get out on the CTAF frequency, and you're going to make an announcement so that other aircraft know that you're flying. It's Class G airspace, so you're okay there, but you still want to let the other aircraft in the area know that you're flying. So what are you saying here? First of all, why do you begin and end with the word Frederick? Because that's the airport it's directed to. So you say, Frederick traffic, this is a drone operation. Be advised that in 2 minutes we'll begin operating 200 feet AGL, approximately 3 miles northwest of the airport, Frederick. And you always open and close your communication with the name of the airport. Now, if you were addressing this to a specific aircraft, instead of saying Frederick at both ends, you would address it to the specific aircraft. So you might, if it was a Cessna aircraft, you might say Cessna. Be advised, this is a drone operation. I'm in the air now. I see you over there. I'm going to try to get out of your way. Okay? Cessna. If you can tell it's a Cessna. If not, whatever you think. And the other thing here is, look, there's lingo. There's in your resource guide, this thing. There's a phonetic alphabet for you. Okay? Learn it and use it. But if you forget what it is or something like that, don't get flustered. Just use plain English. The point is to communicate. So I think we talked about most of this in terms of the different types of frequencies, Unicom, towered versus untowered, etc. I keep going the wrong direction here. Sorry about that. Here we go. So again, plain English works fine if you don't feel like Roger Dodger and Wilco and all that crap, but it doesn't have to be official, and you don't have to speak the lingo. Just get your message across. Okay, so here's a scenario. You're at Travis Airport. Let me see if this other mic is working here. Yeah. Okay, so you're at Travis Airport. You're 3 miles west of the non-towered Travis Airport, operating a quadcopter, stationary at 200 feet. There's an inbound Cessna from the west, and you want to give it a heads up. Does anybody want to give me a radio call? You got any pilots out there who want to give me a radio call? Or should I just read it from the script? No? No takers? Okay. All right. So The call would be okay. The call would be for scenario 1, Travis traffic. This is a drone operation. Be advised that I am operating stationary at 200 feet AGL, approximately 3 miles west of the airport. Travis. It's a straightforward and accurate communication about what you're doing, advising the incoming aircraft that you're there. And if he stays on track, or if he looks like he's on track to even come close to where you are, what are you going to do? You're going to land. You're going to get out of the air, right? So let's try one more. Hagerstown Airport, you've already gotten a waiver to operate in their Class D airspace for this daytime location 4 miles southeast within a quarter-mile radius up to 400 feet. You want to give the area and pilots in the area a warning that you're about to launch your aircraft. So what do you say? How about something like this? Hagerstown traffic, this is a drone operation. Be advised that in 5 minutes we will begin operating between surface and 400 feet AGL within a quarter-mile radius, approximately 4 miles southeast of the airport, Hagerstown. So if I were out there, I would give this call 5 minutes before takeoff, 2 minutes before takeoff, and at takeoff. I'd give it 3 chances just in case anybody didn't hear one or both of the first 2. Let's talk about emergency procedures. So the main thing is, what do you want to do? The drone becomes secondary in this scenario, in an emergency scenario. Right? What you want to do is you want to land, if you get an emergency situation, if you can land and control the drone, you want to land it as far away from people and stuff that it might damage as possible. If it happens to land in a tree or in a field where you may or may not be able to get it, or perhaps in a body of water where you may never retrieve it, the drone should be your secondary consideration. It's about keeping people and their stuff safe. That's your primary consideration. And if you get into an emergency situation that causes you to violate one or more of the FAA Part 107 regulations, such as flying beyond line of sight, or you have to go around behind a building to get out of a manned aircraft's way, or you have to fly above 400 feet for some reason in a legitimate emergency, do it. Don't hesitate, because if you're breaking the rules to avoid creating a problem in an emergency, you're on solid ground with the FAA and it won't be a problem. You may get contacted by the FAA and asked what you were doing, but as long as you have a reasonable explanation, there's going to be no problem. So I think we talked about this. Flyaways, we talked about. The one thing, again, if you're in or near controlled airspace and you get a flyaway situation, notify the controlling agency, air traffic control or whatever agency might be nearest the controlled airspace that you're working with. If you do have an accident, FAA requires that you report it within 10 days if anyone is seriously injured or knocked out, or if property damage greater than $500, not including the UAS. Notice they don't care about your aircraft. It's about stuff other than your aircraft. Stuff and people other than your aircraft, okay? If that happens, property damage over $500, not including the UAS. Now, here's a couple interesting caveats. Damage to property, if the cost is greater than $500 to repair the property or replace, whichever is lower. So let me translate that for you. That's the FAA language. Here's an example. Damage to property whose fair market value is $200. The cost to repair the damage is $600. Do you have to report that to the FAA? No, because the fair market value of that property is $200. Second example is you have $200 worth of damage to property whose fair market value is $600. Do you have to report that? Again, remember the FAA regulation says you report, the threshold is based on the lower amount. So again, it has to exceed $500, and the lower amount in this case is the $200 worth of damage to this $500 property, or excuse me, $600 property.